Hey, good evening, everybody. I hope you're having a really great first 2 days of Autodesk University. I could tell from the conversation in the room that you have already started your networking. I hope you're also enjoying all the classes, been to the exhibits. As I look out among the room, I can see that some of you have been to the creative space to pimp out your badges. That's really good. So, this is a technology main stage. I'm hugely excited about it because technology partners, our hardware partners in particular, have always been particularly important to Autodesk. In fact, I don't know if you personally experienced this, but you probably heard the story. 3 decades ago, Autodesk was in fact born in a period of great disruption, sparked by innovations in hardware. And what was that? It was the innovation of the creation of the personal computer. And our founders at Autodesk really saw over the fence from their current jobs as mainframe programmers and said, hey, wow, there's this big new opportunity out there to take advantage of computing that's being provided in a new way that's, for the first time, accessible and affordable. And they created, really, the industry that we all now enjoy and the types of things that we can now develop for the world. So, continuing on that story, I want to reflect back a little bit on what we discussed yesterday at Main Stage. We're in a period of even greater disruption now, right? I talked about those 5 big waves of disruption. I talked about disruption in form of access. Access meaning that we're making a transition from ownership to experience as the point of emphasis. I also talked about business unusual and the way that that was changing funding and capital structure and even organizational structure. I talked about digital manufacturing, that fabrication of goods directly from the computer so that what you design and what you analyze can be made real instantly. I talked about ambient intelligence, and I talked about smarter buildings, smarter places, smarter people, all made smarter through a smart system that is connected to a constant stream of data fed by sensors. And lastly, I talked about infinite computing, one of my favorite topics, because computing is so ubiquitous now that it can drive much of the design, analyses, and simulations that we desperately need to make sure we're putting the right things on the planet. So those 5 disruptions actually lead to a lot more complexity and opportunity, don't they? And it requires a lot more innovation. You know, Carl followed up yesterday at the keynote by talking about the innovation that's going to be necessary in the form of new tools. That new tool set's super important. That's what's going to enable us to do the right thing. He also talked about software everywhere. And frankly, software everywhere means it's going to run on a variety of different types of devices, giving you the freedom to work where you want, wherever you want. But it's still going to require, until we have the ability to run software on just a vacuum, innovative hardware to really drive the insights that you need in your business. So that's what we're here to talk about tonight. In the next hour, we're going to hear from 4 very innovative leading partners that we work closely with, and they're going to describe to you some of the things that you'll be seeing over the course of the next year. We're going to hear the perspectives of Intel addressing what is planned to make huge, complex design the norm rather than the exception. You'll hear from HP. We've been collaborating with them on a project. They're going to tell us about what's beyond the keyboard and the mouse. Thirdly, Dell's going to tell us about advancements in system components that are going to allow you to do more. And finally, Lenovo is going to share their vision for mobility to drive business and innovation. So the format's going to be, they're going to come up and give a presentation for a few short minutes, and then they're going to join me in a short conversation. And that conversation is going to be driven by the questions that we sourced from the survey from all of you. I think it's going to be pretty exciting. I'm looking forward to hearing what all of these partners have to say, and I hope you are too. So let's get started with the conversation. I'd like to first introduce our first presenter, Joe Curley. He's the Director of Technical Computing Marketing at Intel. Hey, Jeff, great. Thanks so much.
Thanks. A very nice crowd. Hi, I'm Joe Curley. I work at Intel Corporation, and I lead the marketing group responsible for something we call technical computing. It covers the entire continuum from the workstation all the way through the highest end of supercomputing. And we talk about making huge, complex designs the norm. And what's going to make that happen? It may surprise you. And it's funny listening to Jeff reflect on the beginning of Autodesk. And my first experience with AutoCAD was back in about 1986, where products I was working on were able to deliver the first 4:3 aspect ratio, at least affordable 4:3 aspect ratio graphics. Super EGA. And that kind of let people have what you see is what you get in the design phase. We were trying to get to digital design. And as career developed, we went from digital design to digital visualization, accurate idea of what is it that I'm trying to make. Well, we've gone from visualization to analysis. We've gone from analysis now to digital prototyping. Digital prototyping to digital manufacturing. What's the benefit of all of this? Well, your innovation, your insights, your competitive advantages, your intellectual property comes out in product, months, years faster than it would through some repetitive cycle of manufacturing. And what we end up doing at Intel Corporation is trying to build fundamental underlying technologies that enable these types of innovations from Autodesk and all the partners that you're going to see come through. And we're really trying to get to the point where we're no longer inured or we're not satisfied or complacent about being amazed. We're going to do really amazing things together. And you kind of wonder, what is the magic? What's the special sauce that ends up making it happen? And you know what? It's a really simple thing. It's called a transistor. And ultimately, if you look at the scale and how things have changed over the course of time, it goes back to your basics. In any engineering problem, when you have a really complex problem, when you're trying to debug, you go, what are the basics? What are the things that can go right and go wrong? Intel Corporation has invested literally billions of dollars in trying to maintain cutting-edge manufacturing processes. And what this ends up doing is creating transistors that ultimately get smaller, less powerful, faster. And those transistors themselves create the fundamental building block upon which all of that amazing activity happens. And it's not going to stop. Today we're in the process of manufacturing something in 32 nanometers. We've said we're going to be producing this quarter, 22 nanometer technology. But more importantly, we've made the leap into Tri-Gate, or three-dimensional transistors, that ensures the density of design and the number of transistors in area and power will continue to double at half the power, or roughly be what Gordon Moore forecasted 4 decades ago was going to happen. I'm proud to report that Moore's Law, because of these innovations, is alive and well. And what does it mean? What it ends up meaning is that we're going to be building really wonderful designs for all the different types of things you want to do. We talked about doing work in a mobile environment, but accessing a server or accessing your workstation. In some of the really wonderful demos you see on the floor, you see groups of workstations put together to create high-performance computing clusters. You know that in the first quarter of next year, a mainstream 2-socket workstation that you can buy from one of these vendors that will be talking to you is going to have the power and memory capability of the number 166 supercomputer in the planet only 6 years ago. And what can that do for you? What kind of things can you change in your life as part of the richness of experience? But what we're going to be doing is focusing on building the right ingredients, the right I/O technologies, the right memory technologies, all of the most important things that it takes to build a wonderful platform, the types of things you're going to hear, and build them into many, many, many different devices. Little processors, low-power processors, highly parallel processors, processors optimized for your design, for your simulation. Well, that creates a problem. And your problem is that the programming models and the investments that these guys have to make to be able to power all of those solutions could become insanely expensive. And here's the beauty. We're going to be able to take a programming model that you have all the way back to 1986, the first AutoCAD that I worked with, all the way to the Exascale, giga, mega, tera, peta, exaflops, exabytes per second. And we're going to do it across this entire continuum from the on-ramp to your cluster, to your workstation clusters, all the way to your supercomputers. So we're going to keep working on that little transistor and integrating them into the wonderful base platforms that the rest of the vendors will tell you about what they're going to do with. Hey, thanks very much.
So Joe, you quickly breezed over that term exascale. Could you redefine it for us, just so we understand exactly what it is and let us know why it's going to be relevant to the way that we do business?
Yeah, so today, supercomputing is, we announced a couple weeks ago a single chip, that actually delivered the full power of 1997's first teraflop computer on a single chip in the power envelope of
on one chip.
One chip, yeah, that you can put into a workstation type format. Not available today. It'll take a little while before you see it in the market. That's the terascale. Okay, go jump up another 3 orders of magnitude. You get to the petascale. You get beyond that, you go to exa. At exascale, you can try to predict where a hurricane will land. I guess 10 days, 12 days in advance of when it hits the shore. I mean, real massive computing. But the thing about exascale that's really funny is that there are some people out there talking today that said, in order to get to this level of power performance, you're going to have to throw away your entire past. One of my coworkers goes, yeah, in order to be able to advance knowledge, we're going to have to face the choice that they did when they burned the library at Alexandria and lost all the knowledge of the known world. Well, what we're going to do is we're going to drive to the exascale. And what if you have to change everything, all of your current designs go away. All of your applications go away. Everything you've invested in for the last 30 years goes away. We're going to provide a very linear path to be able to scale that up to the exascale and have to break through. So it's just going to be entirely new levels of creativity and insight.
So is this related to the plumbing example that you were talking about, or is this something different?
Plumbing, yes. So again, if you think about what the plumbing is, we had all those different looks at chips. Yep. And what you're saying is that when you get to this type of order of magnitude, what's the right box for me? What's the right processor for me? If I'm on a handheld, is that the same thing I need in a supercomputer? Probably no. What we're investing very heavily for users for Autodesk is in taking a look at how all of your products work, optimizing the microprocessors, optimizing the memory, optimizing the I/O, building the plumbing that will allow a platform to exist, and hopefully allow you to jump on top of that and really create the real innovation which comes out of the software.
Better processors, tightly coupled plumbing. What else?
Actually, when you get to what else, then it becomes an ecosystem. All the fast processors in the world bring capability. Mm-hmm. But actually, it's what you're talking about through the rest of the week that's going to bring out the value. So what I think after that, it's a matter of partnership.
Very good. Thank you so much. I really appreciate it.
Great to see you. Thanks for having us.